The AI revolution has swept through the tech world like a whirlwind, transforming what once seemed like science fiction into our everyday reality almost overnight. Leading the charge is Nvidia, a company that, not long ago, was primarily recognized for its video game graphics. Nvidia's shift towards AI computing stands as one of the most extraordinary business transformations we've ever witnessed. Nvidia was founded on April 5, 1993 by Jensen Huang, CEO as of 2024, a Taiwanese-American electrical engineer who was previously the director of Coreware at LSI Logic and a microprocessor designer at AMD. Chris Malachowski, an engineer who worked at Sun Microsystems, and Curtis Preem, who was previously a senior staff engineer and graphics chip designer at IBM and Sun Microsystems. The three men agreed to start the company in a meeting at a Denny's roadside dinner on Berryessa Road in East San Jose. At the time, Malachowski and Preem were frustrated with Sun's management and were looking to leave, but Huang was on firmer ground, as he was already running his own division at LSI. The three co-founders discussed a vision of the future so compelling that Huang decided to leave LSI and become the chief executive officer of their new startup. In 1993, the three co-founders envisioned that the ideal trajectory for the forthcoming wave of computing would be in the realm of accelerated computing, specifically in graphics-based processing. This path was chosen due to its unique ability to tackle challenges that eluded general-purpose computing methods. With $40,000 in the bank on April 5, 1993, the company was born. The name Nvidia is an amalgamation of two terms, Nvidia, with the Latin word for envy, the acronym NV, or Next Vision, which the company used early on to label its files. In the year of its founding, the company received an initial investment of $20 million in venture capital funding from firms such as Sequoia Capital, giving it the early financial support and market credibility that would lead to its initial public offering, or IPO, 6 years later in 1999. The company's initial focus was on graphics-based computing and video games. This became a major differentiating factor and, in time, a competitive advantage for Nvidia. The company became a pioneer of GPU technology, capitalizing on its multi-core and parallel processing speed, both lacking in standard CPU processes. In 1997, Nvidia gained a foothold in the computer gaming industry with the launch of the Riva series of graphics processors. The following year, 1998, the company released the Riva TNT, a PC graphics accelerator chip that helped expand Nvidia's reputation. In 1999, the year that company went public, Nvidia released the GeForce 256. This product introduced onboard transformation and lighting, or TNL, to consumer-grade hardware. The success of these products won Nvidia the contract to develop the hardware for the Xbox, Microsoft's gaming console. Nvidia received a $200 million advance for the project. The early 2000s also saw Nvidia shift beyond the gaming industry, a move that the company would expand on throughout most of the decade. In 2003, Nvidia worked with NASA to develop a photorealistic Mars simulation. Nvidia also became a major graphics chip supplier for several Audi vehicles. The company's growth was publicly recognized when, in 2007, Nvidia was named Forbes' Company of the Year. Soon after this crowning accolade, however, the company faced a series of setbacks that mired the chipmaker in legal hurdles and lost business opportunities. At the center were reports that certain mobile chips and GPUs had abnormal failure rates. Due to manufacturing defects, despite the red flags, the company did not reveal which products were affected. As a consequence, Nvidia found itself on the receiving end of a class action lawsuit, which was settled in September 2010. In January 2011, Nvidia signed a $1.5 billion cross-licensing deal with IBM, which ended all pending litigation between the two firms. With keen forward-leaning insight, the company's development in parallel computing technology helped it recover from its end-of-decade slump and launch its leading position in the emerging field of artificial intelligence, or AI. Nvidia's seminal step toward later AI and deep learning technology began back in 2006 when it released its Compute Unified Device Architecture, or CUDA, platform, a major innovation in GPU-based parallel computing technology. While the company continued to develop and eventually monetize AI technology, it added other revenue drivers to its core gaming enterprise. Strategic acquisitions have been part of Nvidia's growth since its purchase in 2000 of graphics card maker 3DFX Interactive, its 2011 acquisition of mobile communications equipment maker Icera, followed by compiler tech maker PGI in 2013, kicked off a decade in which Nvidia used its resources not only to fill technology gaps, but also to enter new markets. By the end of the decade, Nvidia had initiated more than a dozen acquisitions. In 2011, Nvidia released its first-generation Tegra, a system-on-a-chip or SoC series developed for mobile devices, such as smartphones, personal digital assistants, and mobile internet devices. The Tegra integrates an ARM architecture central processing unit (CPU), a GPU, Northbridge, Southbridge, and memory controller onto one package. It's designed as an efficient multimedia processor. The Tegra line evolved to emphasize performance for gaming and machine learning applications without sacrificing power efficiency, before taking a drastic shift toward platforms that provide vehicular automation under the Nvidia Drive brand. In 2017, the company announced a partnership with automaker Toyota, which would use Nvidia's Drive PX artificial intelligence platform for its self-driving cars. The Nvidia Drive chip enables vehicles to analyze the surrounding environment via cameras, radar, and LiDAR technologies. Nvidia also partnered with Baidu, a Chinese multinational technology conglomerate, which uses the Drive PX series in its self-driving car initiative. Nvidia's growth was also fueled by a combination of strategic acquisition and a robust culture of innovation. One of the most notable moves was the acquisition of Mellanox Technologies for $6.9 billion in 2019, a purchase that expanded Nvidia's capabilities in high-performance computing and data center networking. Building on this momentum, Nvidia attempted another audacious acquisition, ARM Holdings, for $40 billion. Although the deal faced significant regulatory hurdles and was eventually abandoned, it underscored Nvidia's ambition to dominate the semiconductor industry by merging ARM CPU's design prowess with its own GPU expertise. The news of the deal impacted Nvidia's stock price, with shares falling by around 2% following the report. However, Nvidia's journey has not been without its challenges. In 2020, Nvidia released its beta version of Omniverse, leveraging its graphics leadership to develop 3D imaging design and engineering. The Omniverse was built from scratch to mimic the real world, thanks to Nvidia RTX graphics technologies. It is fully path traced, simulating how each ray of light bounces around a virtual world in real time. In 2022, Nvidia's investment in artificial intelligence paid off by focusing on processing speed and production speed. And by investing heavily in deep learning and AI applications, Nvidia was able to not only expand on GPU capabilities, but also contribute greatly to AI innovation. When word got out that OpenAI's ChatGPT platform, which set off a global rush toward AI technology, was built upon 10,000 Nvidia GPUs, rival platforms clamored for Nvidia chips. Nvidia's strategic shift from gaming to AI has been highly successful. On March 20, 2024, Hitachi Tokyo announced it's collaborating with Nvidia to accelerate social innovation and digital transformation by combining Hitachi's domain solutions in operational technology and leadership in key industries including energy, mobility, and connected systems, with Nvidia's expertise in generative AI. The future of Nvidia lies in its continued innovation in hardware and software solutions, the potentially transformative impact of artificial intelligence, and in using its dominant position in GPUs to help shape the landscape of emerging technologies. If you enjoyed this video, like and subscribe for more innovative content.